Hello, welcome to JSON webinar about JSON benefits in drone photogrammetry projects. My name is Elsie Hernandez. I am JSON Key account. It's 6:30. We are giving 5 minutes as a courtesy because we still have people connecting, and also for those who doesn't download the application from WebEx. And after this time, I will pass the totem to Xavier Banquet, the Rockubon CEO. So we are going to start the 5 minutes courtesy right now.
I guess you can hear me properly. Thank you so much for attending. Welcome to this maiden webinar about JSON, which is our PPK service at Rockubon. I would like to first of all thanks to all the attendees for your attention. I hope that's going to be a useful pill about how to use JSON and what benefits can the service introduce into your drone operations. But given the fact that it is the first webinar we are giving and that the JSON is some sort of a newcomer in the GNSS technology, in the GNSS vertical, I'm gonna let you know a little bit first about Rockubon and then about JSON, and then I'm gonna pass the token to Isaac for the demonstration and for the core content of the webinar. So Rockubon's it's a tiny company. It's an SME dealing with advanced satellite navigation solutions, and we're in quest of a very specific concept, which is what we call accurate and affordable geolocation. So essentially, Rockubon's vision is democratizing precise navigation for mass market applications. In that line, JSON's our first value proposition, our first commercialized value proposition, and it is essentially for those not familiar, it is essentially a GNSS service in the cloud that provides precise navigation in post facto. So for those acquainted with GNSS, it is a PPK service. So it's the post facto version of an RTK service. And the idea is that we try to make it easy what it is normally difficult and cumbersome in the GNSS processing world, right? So the idea is that you do not require very specific and strong GNSS expertise to use JSON to obtain very precise navigation information for your operations. Today, we're going to talk about drone photogrammetry operations, but there's other alternatives. I don't know, mobility as a service or sports, motorsports, whatever. So let me tell you one last thing, and then I'm going to leave my token to Isaac. I would like to recall that the service is free, right? The service is works under a freemium business model, which means that you have a free tier with which you can use the full-fledged service for a free tier of 10,000 epochs every month. So every month, this free tier is going to reset, and it's going to allow you to enjoy the full-fledged service for free at absolutely no cost, 1 month after the other. That's just a reminder, essentially to encourage you for using the service. That said, I think it's rather all on my side. Only a minor detail for what it comes now in the webinar. Please address your questions to the Q&A chat in the WebEx application, and address all of them to the host, because the host is going to manage the questions and answers, and at the end of the webinar we'll try to respond as many questions as we can, essentially the main ones. So that's it. I'll leave the token to Isaac, and I'm gonna mute my microphone. So enjoy the live demonstration on webinar. See you later.
Thank you very much, Xavi. Hello, everyone. My name is Isaac. I am a navigation support engineer at Rockubun. I graduated land surveying at the UPC, or Universitat Politècnica de Catalunya. I worked for 7 years at Novotel, which is a major GNSS manufacturer, where I learned quite a bit about GNSS. And I worked also in the photogrammetry sector. I had my own little company, and I also worked as a lecturer at the UPC University. So for today demonstration, we are gonna dive into a map of Spain. This is Catalonia. As you can see, you have Barcelona, and there is a little town called Granollers, and a little bit further north. Sorry, I'm being told that I am not sharing the screen, so just wait a second, please. Okay, now I think I'm sharing the screen. Okay, good. Okay, so I will go back so that you can follow the explanation. So this is Spain, this is Catalonia. We are diving to Barcelona, and a little bit north east, you have a little town called Granollers, and a little bit further east, Cardedeu. Today's demonstration is going to happen around this land. As you can see, in the east, we have downtown Cardedeu. In the west, we have a little golf course. North, we have some fields, and south, we have some other fields. So if we zoom in into Google Earth, we will typically see what we all have seen before, which is a fairly reasonable resolution orthophoto. But we will see what we can do with JSON today. So, as I was saying before, I prepared a flight plan of the area of interest. And as you can see, it's a pretty straightforward, pretty standard photogrammetric flight plan. You have 12 parallel passes for a total of 436 images. And the flight plan was executed by a DJI Mavic 2 Pro drone. As many of you probably know, this is not a PPK-enabled drone. It's a standard drone, commercial off the shelf. You can purchase, and it's going to fly, very good. But you are unable to record raw data, which is what we need for processing, for post-processing. So what we did is to add a PPK key to the drone. This is made by a company called Topo Drone. As you can see, it's the add-on that we put in front of the drone, which has a black antenna on top, a little SD card slot on the left side, and let's show a sideways view. This is it. There is nothing else to it. Basically, as soon as you power on the drone, this kit starts recording raw data. The drone is equipped with a 20 megapixel camera, which is a reasonable quality camera for photogrammetric work. And with all this system, we can use JSON without any issue. The format of the files provided by the SD card is understood by JSON right away. So what we have here is the interface. Let me just log out. what we have here is the landing page of JSON. If we log in, we will see the page we were showing before, which is the standard interface of JSON. As you will see, it's extremely straightforward. There is not much to it. Just you can drop the GNSS file out of the SD card of the Topodrone kit here. So basically, I pick the file and I drop it. You add a little bit, a short description. In this case, let's go with the test. The parameters that are set here are correct. So basically, this is telling the system to use a dynamic trajectory, which is because the drone was moving, it's dynamic. It's not static. And that's the processing strategy, which is PPK. It's the highest possible accuracy that the system is going to deliver, which is what we want. And last but not least, we will add the images. This time, I'm not going to use the drag and drop because you already saw that. I'm going to just select the images. So Control A to select everything and just click open. You will see that there is a little progress bar rising to the right. And as you can guess by the speed of this progress bar, we are not uploading all the images. We are just uploading the header of the image. Otherwise, it would take quite a bit to upload everything to the servers, and it would slow down the process unnecessarily. We are just uploading the metadata of the images, that is position and approximate time of each picture. I'm going to launch the process, and you will see that JSON is going to provide feedback step by step on what is he doing. So while JSON progresses in the processing, I would like to point out that while in this processing, I did not upload any base station manually, you can do so if you want. If you have your own base station or you are operating on a place that is not covered by a base station, you can upload your own base station. After we finish the processing, which it's not going to take much, we will see a map where you can check if your work area is covered or not by base stations. So you can decide, you can take an informed decision if you want to upload your own base station or not. Right now, it's finishing the processing. Just look at here. The system has found the system has found 436 images, which is exactly the number of images that I have uploaded right now. And we go to the results page. So, as you can see here, I am presented with a very simple summary of the solution. You can see a plot of the height here, which I'm going to comment a little bit later on. Sorry. A sky plot of the GNSS satellites in view at the moment, and the number of satellites in view. You might wonder why the height is so jaggy. That's normal. That's because the drone was set up to follow the terrain. So the drone was going up and down, following the hills of the terrain. That's the reason. So let's download the results so that we can further analyze this. But while it's downloading, I would like to address one thing that I forgot before, which is, as I said before, there is a coverage map, which you can search. For instance, I told you that we were working near Granollers, which is a little town up northeast of Barcelona. And as I zoom in, I can see that in here, I can see Granollers. If I click in one of those bubbles, I will see the description of the base station coordinates and the network that is this base station part of. So let's go to the results. Let's decompress the file. And here we can see few files and pair of folders. Probably the most familiar format for everyone is KML. You can import that into Google Earth. So we are gonna briefly look into it. And as you can see, here is the trajectory of the drone over the area of interest. I would like to point out that the height of the drone is in ellipsoidal height, not orthometric or above mean sea level. This is to take into account that the base station is usually provided in that particular format. So we are not converting anything. We are exporting everything in ellipsoidal height. And probably the file that we would work on later on is this one. Let me show you. This is a very simple ASCII file where you can see the name of the picture, the latitude, the longitude, the height, again, ellipsoidal height, and the accuracy, as it says on the header. This file format can be imported in any of the standard photogrammetric softwares like Pix4D or Agisoft Metashape, and we will see that in few moments. So let's open an empty Metashape project so that we can quickly assess what would be the normal procedure. So the first step would be to import all the pictures in Metashape. As you can see, it's a pretty quick, straightforward process. We can see the pictures here, but I would like to point out that the positions that we see here besides each picture name are the navigation solution position. That means that those coordinates are not accurate, and as the accuracy column suggests, should not be trusted for any serious work. That's the reason we want to import the result from JSON. So let me just search. Okay, come here, events. Now we can see the usual import wizard, which allows us to select the format. In this case, it's already configured, so we can see that the columns correspond to the expected values. So I'm just gonna click OK, and you will see how the coordinates up here change, and the accuracy goes down pretty heavily. So basically now the coordinates that we have here in all those pictures, sorry, are the accurate coordinates of each picture. The next step that I want to do, which is very important, is to import the camera calibration. This step cannot be disregarded. If you want to work with a PPK drone and you care about the height, it's very important that you import a calibration file. And not only that, but also that you lock down all the values, as otherwise you would be changing those values, which we don't want to do. We want to always use a camera calibrated, always, no matter what. If you only care about the planimetric solution, that is the 2D horizontal solution, that's fine. You can work without a camera calibration. But if you want to work in the height with the height value, you want to import the camera calibration. Okay. So because the processing takes quite a while, I'm gonna close this project, and I'm gonna open a ready-made project, something that has already been processed, as otherwise it would take hours to reach the solution. So, okay. In here you can see the point cloud that we recorded with a drone. This point cloud is a spare point cloud. It's not the final product. It comes from the matching between images. So if we enable the cameras, we can see all the cameras with the names, and sorry, we can pan and see the relationship between the cameras and the point cloud. You will realize that there are little flags with a number, and many of you will recognize that as a ground control point, or GCP for short. That's true, they are ground control points, actually surveyed with a dual frequency receiver. However, those ground control points were not used as a ground control point, but rather as a checkpoint, because we were interested in knowing the accuracy of the final product rather than correcting the result. So they were not part of the aerial triangulation. So I'm gonna very quickly pan around the point cloud. There is not much to see, just I would like to point out that if we look at the quality control coloring, so basically the point cloud variants, we will see that there are no internal strains. There are no zones that have red or yellow or green color. Only the areas that have vegetation, dense vegetation, which are trees and bushes, are marked as red, and that's because the bushes and the trees move with the wind, so that's expected. So again, if we look at the quality control of the dense cloud, we can see that everything looks normal, and basically the pictures have done a good work. So basically the information from JSON processed correctly. Okay, wait a second, please. Just trying to. Okay. Okay. This, what you see here is a standard 3D model. So if we get very close and I turn on the wireframe, you will see that they are triangles. The reason I did that is because that's the way to compute a DSM and a DTM. So you can separate the vegetation from the ground and the buildings from the ground. So that would be the DSM, as you can see. You can see trees, you can see buildings, you can see anything that protrudes from the ground, then you can see the DSM. And also the orthomosaic. This orthomosaic, as you can see, matches very well the images. Okay, if I zoom in, still matches very well. You will see that all of a sudden the image of the background changes and there is no overlap anymore. That's because of datum and different sources of the image in the background. That's not because the solution that we obtained is wrong in any way. Otherwise, we would see that thanks to the GCPs that we have set up, which is those little flags. So now, let me show you the end result. The end result is this report which, by the way, is not altered or changed or modified in any way or sort. It's the report that pops off the software, and you can see all the standard pages, the camera results. As you can see, very good results. The pixel scale here is really, really good. Here we see the error on the camera locations. Again, the scale is really good, 3,000 times. So that looks very good. And here you can check that I am not lying, which is basically all the checkpoints that you can see that they are not control points, but rather checkpoints. And the table below, you can see that the error, even though the ground sampling distance of that ortho image is a little bit less than 3 centimeters, we are obtaining a planimetric error of 5 centimeters and a total error of 5.6 centimeters, which is actually really good. Okay, and that would be the final result. That, what you see here is an orthomosaic from an official source, to be precise, the Institut Cartogràfic and Geològic de Catalunya, which is the official cartographic institution in here. And then we can see the result. Please bear in mind the vectors that come from the 5000 cartography. And here we can see the 3 centimeter GSD's resolution, which is actually way better. And if we go back and forth, if you look into the trees or maybe the manholes, you will see that the quality is very good. And actually, you can also see that there is no displacement pretty much at all in between the official source and the final solution that we obtained from Agisoft Metashape. That would be the same result, just displaying left and right. The left one is in black and white just to display it a little bit better what I was trying to explain before. And yep, that's pretty much it on my side. Now I think we will.
Yeah, thank you so much, Isaac. Let me take it back on my side. Thank you so much. It's been great. The presentation's been awesome, pretty clear. Essentially, I think that you've proved that you can use JSON without using ground control points for very professional and good performing drone photogrammetry results, which was the goal of this webinar. I hope it was ready for all the attendees. Otherwise, please start addressing your questions to this Q&A chat tool of WebEx. Yeah, I think that's it. So let's do as follows. We in the weeks before the webinar, we commented that we'd be giving away a couple of Argonauts in case we reach 200 attendees for the webinar that were yeah, unfortunately not achieved. But we propose you to do as follows. We're going to send you a very brief Google Forms with a quiz about the webinar in JSON. For those participating in this quiz, we will give away these Argonauts. So those participating will be in the draw for an Argonaut. The elected one's going to be contacted after filling in the form. So it's all on my side. I will leave the token to Elsie for the farewell, and yeah, let me thank you again your attendance. See you next time. Elsie.
Okay, yeah, sorry, okay. Yes, thank you for your attention. Please feel free to contact our support team to support@rockable.cat so you can send any question or any doubt about JSON. And yes, through social media as well. Let's keep in touch, and thank you very much again for your interest in JSON. See you soon. Bye-bye.